Now we are going to see about estimating the number of clusters in K-means clustering algorithm. Yeah, estimating the number of clusters. The problem of estimating the correct number of clusters is one of the major challenges for K-means clustering. Several researchers have proposed new methods for addressing this challenge in the literature. We will briefly describe some of the most prominent methods. Kalinski Herbes's index. The Kalinski the difference is here. The difference is here given. CH of k is equal to b divided by k, b power k, b of k equal divided by k of k minus 1 divided by w of k divided by n minus k. This is the equation for Kalinski Herbes. When n represents the number of data points, the number of cluster is chosen by maximizing the function given in equation. Here, b of k and w of k are between and within the cluster sum of square respectively with the k clusters. Gap statistics. In this method, b different data sets each with the same range values as the original data are produced. The within cluster sum of square is calculated for each of them. With a different number of clusters, WB into K is within cluster sum of squares for bth uniform data set. Here, gap of K is equal to 1 into log W into K minus WK. W of K. This is the equation of gap statistics. Next, alkaline information criteria. AIC has been alkaline information criteria has been developed by considering the log likelihood and adding additional constraints of minimum description length MDL to estimate the value of K. M represents the dimensionality of the dataset. SSE, we will come with another question. Is the sum of square errors for clustering obtained using K. K means uses a modified alkaline information criteria as given. K means where A minus E is K equal to R minimum K into SSE of K plus 2mK. It is the equation of alkaline information criteria. Bayesian information criteria, BIC. Bayesian information criteria serves as an asymptotic approximation to a transformation of the Bayesian posterior probability of a candidate model. Similar to alkaline information criteria, the computation is also based on considering the logarithm of likelihood L. N represents the number of points, the value of K that minimize the Bayesian information criteria function given below will be used as the initial parameter for running the K-means clustering. Here, K-means clustering for BIC here BIC equal to minus 2 into log minus 2 into ln divided by n plus k into ln divided of n divided by n equal to 1 by n into of n power k divided by L2. This for Bayesian information system equation and other estimating the number of are there, but it is not so important for us. Let's I read the name of those that Duda Hart Silhouette config coefficient, Newman and Griven ISO data. For It's not so important, but these are the estimating the number of clusters in this. Next, variation of k-means clustering algorithm. The simple framework of the k-means algorithm makes it very flexible to modify and build more efficient algorithm on top of it. Some of the variations proposed to the k-means algorithm based on choosing different representative prototype for the clusters, k-medoids, k-medians, k-modes. But here I'm going to discuss only k-medoids, but not, it is not so important, but I will discuss only k-medoids. Choosing better initial centroid estimates, intelligence k-means, genetic k-means. I'm going to only give 3 different prototypes, k-means, genetic k-means, genetic k-means. Applying some kind of feature transformation technique, weighted k-means, kernel k-means. In this section, we discuss only about k-medoids clustering. K-medoids clustering. What is k-medoid? K-medoid clustering algorithm which is more resilient to outliers compared to k-means. Similar to k-means, the goal of k-medoids is to find a clustering solution that minimizes predefined object function. The k-medoids algorithm chooses the actual data points as the prototype and is more robust to noise and outliers in the data. The k-medoids algorithm aims to minimize the absolute error criteria rather than the SSE. Similar to the k-means clustering algorithm, the k-medoids algorithm proceeds iteratively until each representative object is actually the medoid of the cluster. The basic k-medoids cluster algorithm is, it's later I will tell. In the k-medoids clustering algorithm specifies the cases are considered where an arbitrary random point x1 is used to replace a representative point m. Following disrupts the change in the membership of the points that originally belonged to. Then change in membership of these points can occur in one of the two ways. These points can now be closer to x1 or to any other of the sets representative points. The cost of swapping is called. The algorithm of k-medoids clustering. That's what I will tell. Select k points as the initial representative objects. Repeat the same process. Assign each point to the cluster with the nearest representative object. Okay. Randomly select a non-representative object. Compute the total cost x for swapping the representative object m with x. If x is greater than 0, then swap m with xi to form the new set of k representative object until convergence criteria is met. It is then k-medoids clustering algorithm. Next. This is the application of k-means algorithm. K-means algorithm is very popular and used in a variety of applications such as market segmentation, document clustering, image segmentation, and image compression. The goal usually when we undergo a cluster analysis is either get a meaningful intuition of the structure of the data we are dealing with. Cluster then predict where different models will be built for different subgroups. If we believe there is a wide variation in the behaviors of different subgroups, an example of that is clustering patients into different subgroups and build a model for each subgroup to predict the probability of the risk of having heart attack. Two cases, geyser eruption segmentation and 2D image dataset. Thank you.